So this is going to be another unedited long form sort of video. We're going to take this component here, which is an PCB Sled. So this goes inside a rocket essentially, and you'd have a PCB here, which is the flight computer, and I'll just show you how it works here. Let me get the tools on. So you can get 3 of them, you can get slightly different arrangements, and you can hook them all together and they go in the middle, and you have rods that go down here, and then that's inside the rocket. So as you can see, quite a complex part. So it's symmetric almost rotationally, so it's like the bottom half and the upper half are essentially rotated around the origin here, but it's also symmetric in the middle vertically. Like it's got a mirror symmetry here, so it's got 2 kind of opposing symmetries here that's going to make it really complicated to model. So the point of this video is I'm just going to guide you through modelling this, not as a direct tutorial, but just to kind of give you an idea of how I would approach a problem like this, and just to get you an idea into my thought process while I'm modelling. So let's just get started. So the first thing we're going to do, we're just going to create a little, so I've got these all arranged separately here in little containers, or what do you call it? Collections. There we go. My God. So we're going to start off, again, this is quite a small part as well, we're going to start off just get a general shape, and then we can get more precision once we need it. So what we're going to do here, I'm just going to snap the cursor. So once you go into edit mode here, so you can see the reason we are retopologizing this is because this was exported essentially for 3D printing, right? So God knows what's going on here. This is the kind of thing you would get typically when you mesh something in a software like Fusion 360. You would get this sort of very all over the place topology, because it's it only adds vertices where it thinks it needs them, so it doesn't add any vertices here, so it doesn't retopologize anything properly for you. So we're going to fix that. We're going to go in edit mode here. We're going to right click, snap vertices, we're going to tap cursor to selected so that we have the 3D cursor there. Then we can select this face, and we can just go S, make sure that this is set to 3D cursor. We'll go S, Y, 0. And then that aligns that perfectly. And you know it's aligned perfectly when you start to get this Z fighting here. Don't worry about that for now. But what you can do, just remember to, we're going to change the clip start and clip end, because we do not need to see 1,000 meters out here. This thing is about 100 millimeters tall. So let's make it 10 meters here, and then we can take this down. So usually if we don't take this down, then it starts to clip quite early and zooms in here. And if you're trying to get really close in, it just starts to clip things off. So you can set this to like 0.1 millimeters. And there we go, now you can zoom a lot further in. Cool. So you can do that thing with the 3D cursor. Another thing you can do, set the cursor back to the world origin. You can select one of the meshes, shift select the other mesh, and open them both in edit mode at the same time. Now you have to be careful here because you can select the wrong thing and screw up the whole model. But what you can do, if we select this face, so we're going to face mode, select this face, go into vertex mode, and then select one of the vertices we want to align it with here. And then we set this to active element. We can then just go SY0, and it lines it up because this is the last thing that was selected. So you can tell the last thing that's selected is the thing that's highlighted in white here, and it uses that as a reference point. So that's what we're going to do. We are going to just bring these all up here. But you got to be careful. See, when you open these both, sometimes say if you have something selected here and you have something selected here, if you open them both, it'll select them both. So you need to be careful. So select this. Actually, we're going to open them both, deselect everything. We're then going to select this vertex and this vertex, and we are going to go active element S0. Or sorry, we're going to select this whole face. Actually, we're going to select this and then SZ0. There we go, just to get that aligned. I'm going to do the same with the bottom face here. We're going to deselect this vertex here. Pull this down. Right, okay. I may split this video into several parts if the video ends up taking too long, but we will see. I think, looking at this now, I think I might actually... Oh, no, we'll come to that when we get to it. I might pull this side in a little bit, if I can. And just hook that, or kind of line that up with this for now. And then we can worry about this edge stuff here later. Then how would one do the... right, okay. Maybe not. Let's pull that back. Let's see if we can't just hook it up to... Or not hook it up, but kind of align it with that. Right, okay. So we're going to get the same thing. We're actually going to pull this side out here. We're going to line this up with, not you. Right, deselect everything. So again, this is why you have to be careful when you're using the when you're opening two things in edit mode at the same time. You can just select the wrong thing. So 3D cursor is good, but this can be quicker. Right, okay. So what we're going to do now, I think we're going to work on the sort of the rod kind of poles here first. So what we're going to do, we're going to work on the top one, and then we're just going to mirror it round. So this is quite complicated because you have to match kind of mirrored topology here. Even though it's not perfectly mirrored, it's like misaligned. It's going to be a bit weird. So I think we're going to do, we're just going to ignore the bottom half for now. And what I'm actually going to do, I'm going to snap cursor to selected here. Oh, sorry, we're going to snap it here first. And when you're in edit mode, you can add extra geometry like this. You can just go up and add like a circle here. So what we're going to do, we're going to set the radius. We're going to figure out what the radius is. So I'm going to guess 15. No, not even close. 5 millimeters. There we go. That's our radius. And I think that is quite a good sort of vertex density there. So we're going to have 8 vertices on that end. Do we think that's too much? No, we'll go with that for now. Worst case, we can change it later. So what we are going to do, we're actually going to put a median point in this first, before I forget to. And then we're going to go snap the cursor back to the world origin. We're going to take this, and we are going to set the pivot point to 3D cursor, and we're going to go SX -1, and that just flips it. Just flips it along the x-axis here. And that gives us that sort of shape there. So now what we can do, we can start sort of getting, I'm actually going to hide this for now, we can start sort of getting rid of some of the geometry we don't need at the moment, and some of the stuff we're going to replace later. So this is where it starts to get quite complicated when you really need to start managing, you need to start worrying about what vertices are on top of each other, because right now there's 2 vertices in the same spot, so we're going to merge vertices, but we're going to set make sure this is quite low, so make sure this is like that. So they have to be right on top of each other to get merged. So what we're going to do now, we are going to leave that there, actually. We're going to get rid of the parts of the circle that we know we're not going to need. It's just kind of this, see? So it's just that curve there, right? I'm actually going to move this back into the sled thing because I put it in the wrong place. There we go. So now we can hide the references if we don't need them. Right. So we're going to connect this to here. And I'm not too worried about making sure we have perfect topology now at the moment. We're just going to try and kind of connect everything up to get the general shape, and then we can screw with the topology in a minute. So let's take, say, from all the way around here. Let's go around this way. Bring that down there, and then we can just go. Nope. Nope. I said 0. So I'm trying to avoid, for now at least, having cuts along this way, because we have this sort of these cuts in here. I want to give myself as much freedom in the future as I can to get that shape, those kind of complex shapes in the middle without completely screwing everything up. So I want to have a kind of grid here that's just completely unaltered by this sort of topology here. So then that connects up to there. And then we're going to do a similar thing that we did just there to this. This says 0, but we need to flip these because it got the normals the wrong way around. And that's something, if you're not seeing the faces like me, if you're seeing them a bit more like this, where you can see all the faces from both sides, what you want to do is you want to turn on back face culling in the options here. That means that it'll only show a face if you're looking at essentially the front face of it. So if the normal vector is opposite, or the normal vector is coming out of the face, then you can see it. But if you see it from the back side, you won't see it essentially. The face just doesn't render. And the reason that's important is just because it's less so for things like, well, actually no, a lot of modifiers use it just to be able to tell which face is the kind of outer face and which is the inner face. And one of the best ways to sort that, if you just mesh, normals, recalculate outside, it'll generally get it right. But sometimes, just like here, it's just not got it right here. So what we're going to do, we're going to select these, mesh, normals, flip. So you want to have these aligned, right? Just so that these faces can all connect to each other. And then you can have this connected here, and then this connected here, right? So we're already starting to get somewhere with this. What we're going to do now, let's have a look. We're going to get this here. And I think we are going to, right, what I'm actually going to do, I'm going to try and get this middle point back. So one of the ways, if you've accidentally deleted the vertex and then realised, oh, I want to keep a vertex here so I can use it as a reference point, say the centre of a circle here, you can go, G along the y-axis there, and then if you turn on, if you come up here, where have you gone? Yeah, auto merge vertices, and then if you do split edges and faces and set threshold to like 0.1 millimeters again, just in this case, and then you can do it along the x-axis, and if they're all perfectly on top of each other, it'll create a vertex where they intersect, and there you go, you've got a vertex where you need it. And now we can snap cursor to selected, and we can make another circle here. 32, we're going to make this like maybe 3 millimeter radius, nope. 4, nope. 3, 5, nope. See, this is where I'm just kind of trying to guess what the exact, I think that's 3, 2, 5. Hey, that'll do, there we go. So you have to kind of, sometimes you have to kind of guess, like if you have dimension drawings and that kind of thing, or if, or whatever, you can just nail that in perfectly, that's not a big deal, but at this point it's just quicker. I just realised I've done this on the wrong side actually, because this is the side where the whole doesn't actually exist. So what I'm going to do is I'm just going to do this trick again, 3D cursor, I have to set the 3D cursor back to the middle, cursor to world origin, S, X, -1, and it just flips it over there. So now, I want to try and keep this cylinder geometry as undisturbed as possible, because I feel like it'll just become an absolute headache if I try and screw with it later on. So, what I'm going to do now, I'm going to add an array modifier, just to make sure that the topology I'm going to create is lined up on this side. I'll show you what I mean by that in a second. So we're going to make plane axes, we're going to make this like 10 millimeters or something like that so it doesn't get in the way. We're going to go in this view, we're going to rotate it by 180 degrees. And then we're going to put that in the tools thing here. I've got another one as well that I was using earlier. We're going to call this tool. You don't have to call it what, you can call it whatever you want, but I usually just go with tool rot 180. So that means it's kind of rotated by 180 degrees there. Then if you go to object offset here, tool rot 180, and just make sure the count's at 2, turn off relative offset and any of the other options. We're also going to hit, I think, merge here and just make this like 0.1 millimeters again. There we go. Right. So now you can start to see what I mean. We need to try and keep these vertices lined up, and it's quite difficult because it's not like it mirrors perfectly along here, it just rotates itself around. So if I run around and move this vertex here, it's now not aligned with that one, but if I move it on this side, it's also now not aligned with that. And that's why it's quite hard. That's why I think the main thing about this is trying to confine complexity. And by that, what I mean is if there's any complex areas of topology, you're trying to, one, keep it in a small area, as small of an area as possible so it doesn't affect the rest of the model, but also think about your edge flow, the fact that say if I was to make, if I was to try and do some stuff with the geometry here, if I wanted to maybe put a cut here, and then make this into a quad and get this face to come down here, God knows what, right? Hold on, I'll show you what I mean. So if I make this into a quad, if I try to use a cut on that, like a loop cut, it then goes kind of around there. If I try to use a loop cut here, you can imagine if it goes down here, it would go, like say from there, from that face down there, all the way up, and then round, and now it's going across this face, and then it goes back down the other side, and then potentially in a completely different face, and then you get all these crazy loops that go all over the place. So you really have to think about which way your edge loops are going. Whenever you try to make a cut, like a loop cut there, you want to think about which way they're going. You can't just obviously just preview them with this. So you want to try and make it so that they don't, let's say, generally it's quite hard to explain with this model because it's such a complicated one, but say you had like a mesh that was like a kind of cubic type thing here. Why is that so small? I don't know what the hell just happened. cube. Oh, it's so big, this one. Yeah. So yeah, if you have faces here, you're trying to keep these vertical faces and these horizontal these vertical cuts and these horizontal cuts separate, so they don't interact with each other. Because if you start getting geometry that goes around here, you might start getting them looping around all over each other, and that is bad. You end up with a bad day. So let's have a look at this. I think one of the best ways we could potentially do this, we're going to give this a try. I don't actually know how good this is going to end up, but the best way is really just to try it at this point. If we just take this and we do this, scale it along the x-axis here, we're just going to give this one a try here. We're essentially just going to see if we can just loop around the inside here and try and keep it as cubic as possible. Part of me thinks this should be fine, but again, I can sit and think about this for ages, or I can just try it, and then worst case, if it doesn't work, I can't do it. Now, the problem with this is we're starting to get very long, very thin faces here, so what I would probably want to do at some point is add like a face, or rather, like that, just to kind of make sure that these faces are at least not too warped. Right, let's give this a try. Like this. So let's have a think about this. How would this work? So if I wanted to add a loop cut here, then that would go round to there, right? Actually, I'm going to kind of pick up some of these as well. We're just going to get this, we're going to scale it, move it down on the z-axis here, we're going to connect this up here. And you can see it's came up there too. And now, what has to happen, it has to go here. Oh, okay, that's what, yeah, make sure, complex topology like this, sometimes holding F just doesn't work the way you want it to. Right, okay, I'm going to turn off the array for now just so you can see what's going on. So, we need to worry about this now. That's actually what I'm going to do. I'm going to get the 3D cursor in the middle here. Because we have this full circle in the middle now, it's a lot easier. We can just select this whole thing and make sure it's a bin box center, vertex mode, snap vertices, cursor to selected. And now what I'm going to do is I'm just going to select this here. We're going to go into this view. And you can adjust these views by just using the numpad. So it's like 1 is this kind of front face, and then there's 3, and then there's 7, which is the kind of top face, but then if you hit 9, it flips whatever face you're looking at. So 3D cursor, rotate this by 90. And then we can again just merge vertices by distance. And remove 2 vertices. You can always check. You should expect it to remove 2 because there's 2 doubled up vertices here. Right, okay. So now let's have a look where this goes. So if I wanted to make a cut here, it would go down here. And yeah, good. Okay, so you can see if I made that cut here, it would kind of make a cut here as well. You can kind of see where that line is here. I know it's kind of hard to see with all of the extra lines, but you can see it comes down here and it goes along here. Cool. So that actually works a lot better than I thought it would. I thought it would be a lot more complicated. So now everything kind of lines up. You're trying to keep these lined up so that if I was to make a cut here, it would just go round this kind of up over the top and through the hole and then back round and loop back onto itself, instead of going maybe, say it goes this way and then it goes to the right and then round. And now if you want to make a cut just on this side, or rather, say if I was trying to make the kind of the middle geometry again, if I was purely trying to make cuts into this face, you might end up with a scenario where making a cut on this face has it go round here and then up and then through the hole. And right now the hole's very evenly spaced. It's got this perfect kind of circular geometry. And you don't want to end up in a scenario where if you're trying to make this kind of cut in here, then you have to screw up this, and because that means you have to do a lot more work just to get a kind of basic shape in here, because it would screw this up. So that's what I mean by confining complexity. You're trying to keep all the complex parts separate, essentially. You're trying to think of them all as individual problems and trying to make sure that they don't affect each other as best you can. Right, okay. So, I believe we might be done with this kind of basic shape, actually. So now what you can do, for now, we can shade smooth. And if you just mark sharp. No, sorry. What you want to do actually is right click auto smooth for now, and then you can just apply it because it starts off as a modifier, and it's just not perfect. Obviously, there's some things you may want to just mark that sharp, and you mark that as sharp, and then you can just shade smooth. And make sure when you shade smooth, keep sharp edges turned on because it'll override it if you don't do that. Cool, right. Cursor hold on, where are we time wise? 23 minutes. Right, okay. I think I'm gonna split this into a second part. We're going so next time of the video we are going to do the other section here. We're going to do this sort of middle cut here and then the little standoffs here for the screws in. So typically this would be threaded. There would be a kind of thread in here, but when it's 3D printed, it's just not threaded and then you can thread it later. So, if you enjoyed this video, I'd strongly encourage you to, for once, like, subscribe. I know I'm asking like that, so I'm not a dick asking for that because I know what YouTube's like, but it's been great to see. I've been good to see the channel start to grow, especially that it's great to see that like a lot of people are actually taking some help from my advice somehow. I don't know how the hell this has happened. People are trusting me, for God's sake. But yeah, so thanks for watching. If this sort of thing interests you, if this is the kind of, if you're an engineer like me, perhaps if you're trying to learn Blender, I'd strongly recommend checking out Blender for Engineers. It's my kind of paid course and community. If you check it out, it's the top link in the description. We go through this sort of thing, a lot of retopology. We take concept specs for aircraft and technical drawings and that kind of thing and turn them into models, and I can show you essentially how to make your presentations and that kind of thing stand out. So say you're going for like funding pitches, or if you are in a startup and you don't want to have to hire this massive 3D modeling team or this branding team and God knows what to try and make your pitch stand out and get yourself some investor money. If you want to learn that kind of thing yourself, some really useful skills to have just generally, and I can teach you. So if you're interested, it's the top link in the description. And yeah, again, thanks for watching. Stick around for part 2. Also apologies for the crap upload schedule. Uni has been a nightmare recently. So yeah, thanks for watching.